Mika. I work for Yahoo Research in Barcelona. I'm a senior research scientist. I've been in the semantic web community for about 10 years. So I started during my master's, did some coding, did some research, and now I'm working for Yahoo on semantic web related projects. But today I'm going to talk about not my work. So this is not about what I do for them, but mostly about data on the semantic web. Since this is a data hackathon, we should talk mostly about data and some of the tools around data. Now, just like Daniel, I have tons of links in my slides. So I think what I will do is I'll put them on SlideShare, and then you can find them there. So my SlideShare name is Mika, P-M-I-K-A, and I'll put it there in a few seconds so that you can follow the links. Depending on what people want to do, we can also go through and look at some of these tools together. But for now, it's just slides and links that you can follow and play with yourself. Okay, first slide. I mean, next. This is the first one. So you're technically correct. This is the second slide. So, okay, so I'll not go back too long, but you know, this guy was mentioned earlier, this Tim Berners-Lee, right? He invented the web. We kind of enjoy it every day. He was also working for a research institute, by the way, when he invented this thing. This quote, vague but exciting, is what his manager scribbled on top. He thought it was an interesting project, but maybe not so well defined, it will never go anywhere. Now, look what happened. So that's interesting, but also what is interesting from the perspective of the semantic web is that he had this vision already at the very beginning, right? He had this vision where on the web there are not just documents, but there are all kinds of other things. There are representations of real-world objects, books, people, movies, all those kind of things. The reason is that he actually, in his illustration, you know, you won't find movies or anything like that because he did this in a research context. He invented the web and hypertext on the internet to be able to share research outputs with other research institutes. But it was clearly there that he imagined that these documents would be talking about real-world things, and those real-world things also would have some kind of representation on the web that he could retrieve and inspect and link. So in that sense, you know, a document would reference a concept, and that concept would also have a URI, right, or some address that you can go to and get more information. Even call it linked information. So you heard, you know, linked data, linked information at least there. Okay, next slide. Okay, so semantic web. So why do we do this? So, you know, if you ask me, the one-sentence summary would be to facilitate information sharing on the web, right? We have ways to share information on the web, but it's mostly document-based, right? We create these HTML documents that are very rich in presentation. They look very good. You can click on them and go to another page. But it's not a very good way of sharing data, right? And what we want to build is this type of data instead of just having a web of documents. Now, of course, the two are complementary, right? So we still want to keep these web of documents. We still want to keep hypertext and HTML as it is, but we want to build things on top so that we can describe also the objects that are mentioned in documents, that are mentioned in data, right? And we want to carry over also this idea of linking, right? So the way that the web has grown and became successful is through links, right? That you could point to someone else's stuff, right? And when you follow that link, you are going to find a bunch of links, and you could discover, you know, a whole lot of information this way. This was very, very critical, especially the first stage of the web, right? When there were no search engines, right? So that was the way of discovering things. And you know that Yahoo started by actually organizing these links, right? And then building up collections of links, because that was the way to discover things. So we would like to carry over this concept of linking, right? We would like to link from documents to data, data about concepts, and then these concepts should also form some kind of a mesh, right? Where I have some representation on the web, and I'm friends with Danielle, so there will be some link from my description to Danielle's description. So, okay. So what are the problems that need to be solved? Well, we need some common formats, right? Some data formats, right? So that's what primarily the semantic web gives, and we're gonna go through that. And then you need some ways of sharing the meaning of the data, right? So if I say person in my own language, which is Hungarian, and you say person in Russian, and you both create some data that talks about people, we still know that these somehow mean the same thing, right? Because they can map it to some universal concept, let's say, of what a person is. A concept that we agree on, and we use consistently then in our data sets. So there are schema languages, right, in the semantic web, which are fairly important. And then all of these are standards. So the good thing is that these are not something spun out by a company and proprietary, but these are open standards that are freely available from the W3C. You can go to specification and you can learn about the standards. You know that W3C is maintaining a good chunk of the HTML, HTTP related documentation, the entire XML stack. So for W3C, it's another stack of specifications. Can you still hear me in the back? Am I talking loud enough?
No, yes.
It's hard to compete with this thing. Okay, and then this is also a research field. So, I don't know how many of you are a researcher or intend to ever become a researcher, but there are people looking into sort of the scientific questions, knowledge representation, data integration, data quality, many other topics, right? How to automate many of these things that you might need to do when you're dealing with data. And then I think the other critical component is that really this is a grassroots effort to a large extent. Daniel already referenced the linked data website. It's not just a website, it's a community, right? It's a group of people who do fantastic things and take the time to publish data sets, right? Also, when we're talking about the government projects, right? A lot of them are actually coming out from individual coders, right? Individual developers who want to do something to improve government, right? In the US, there's this Code for America effort, right? That is completely, grassroots. So people trying to improve their city, people trying to improve their state, people trying to improve how their country operates by asking them to provide the data sets. Government has lots of data, somewhere sitting on a shelf mostly. Right? So the problem is getting this data, but once you have this data, trying to do something that improves the environment around you. So I think that's very important. Okay, next slide. Okay, how many of you have heard about RDF or know what RDF is? Raise your hand. Okay, that's not too many. So that's a good thing for me because I can go through this slide. So RDF is sort of this common data format, right? Now, this common data format is essentially a graph, right? In this graph, there are things, right? This is actually a person, right? And it's linked by an edge to another concept, which is actually the type of this thing. Right? And these relations are labeled, so this says that this thing is of type person. And this thing also happens to have a name, right? Since this is an identifier, this is some kind of a URI, assigning some kind of human-readable label also happens by creating an edge and connecting it to a string, to a literal, right? So in this graph, there are essentially two kinds of things. There are concepts, or entities, or objects, no matter what you want to call them, and attributes, right? These are sort of the literal values, right? Your primitive data types, right? Numbers, strings, and so on. Right? That's it. And that's what we call an RDF graph. So these things, of course, can be chopped up, and part of this graph can be described in different serializations. So I'll show you some examples, and then we're talking about an RDF document. So an RDF document is just a description of such a graph in some machine-readable format, right? It's obviously not machine-readable, it's just a slide, right? Okay, next slide. Okay, and then of course you put these things on the web, right? So you take these documents and you host them on some web server, right? And since we're using URIs to identify things, links are sort of created by simply referencing concepts from other documents somewhere else, right? The fact that they are part of the document doesn't even matter at this point, right? Because once you collect all these documents from where they are, from the different servers, right? It's just one big graph, right? So in this example, this person who is Roy, a colleague of mine, actually had this simple document posted somewhere, which actually referenced a type. Now this type happens to be described in yet another document, sitting on yet another server. And this can be referenced, of course, from multiple locations, right? So maybe his employer, will also post some information about him, right? And could reference the same type. And also at the level of entities, right? We can say that these two things are actually the same, right? Initially, we didn't know that these two documents maybe refer to the same thing, but then somehow we discovered that that's actually the same person. And we put a link in between these two, right? And said that the two objects are the same. And then it's up to you then to decide what to do with this information. Whether you want to somehow merge the information that you found here, the information that you found there, or, for example, trust this place more than you trust that place. These sort of things are then up to you as a programmer or developer to decide. But this framework basically gives you this web-like context where you can refer to data in other places, and you can establish these links between things that you think are the same. Okay, is this more or less clear so far? Yeah. Okay, good. Okay, next slide. Okay, so we didn't really talk about schemas yet, but they are also important, right? So in the previous slide, we had this person class, right? And I already told you that this is also defining some kind of a document, right? Now, these documents use, again, standard languages to define what a person is and what kind of attributes a person may have, right? So that just like in other, object-oriented programming language, you would define person class and you would define the attributes of the person class. Here, you would find a document which says that the person class has these and these attributes, okay? And what the valid values are. So, for example, name is a string, but age is an integer, and it runs between 0 and 200. So these documents are typically using a language called OWL, which is a web ontology language, and again, it's W3C standard for creating these schema definitions. It is very powerful. It is way, way too powerful than you will probably ever need in practice. But it can do similar things that you could do in object-oriented programming, right? In UML. You can create subclasses, superclasses. You can say that this attribute is required, but that other one is optional. You can define the ranges, as I already mentioned. You can even limit the ranges, right? So you can say that age is between 0 and 200. It's fairly flexible in the sense in the interpretation of what an instance and a class is. So an instance can have multiple classes, a class can have multiple superclasses, and in fact, there's also meta modeling. So a class can also have a class, and all these crazy things. And then, as I said, also the attributes, which are more often called properties in this context, they can also have a fairly rich characterization. Okay, next. Okay, so one example that I wanted to bring up for schemas is schema.org, one of the projects that, I promised I would not going to talk about my work. Okay, so one of the projects that I'm actually involved in through my work, which is a collaboration between Bing, Google, and Yahoo initially, and now you have Yandex on board as well, where the idea is to create a set of reference schemas, let's say. So schemas that people can use on their own websites, in their own data sets. And if they adopt these schemas, then at least all this sharing becomes a bit easier, right? Certainly for the search engines. So just switching back to this context of my everyday life, right? If you're in the search engine context, you would want to understand web pages. Now it's fairly difficult if, of course, people use all kinds of schemas to describe their data. So maybe there are two product pages. They are both talking about the weight of the product, but one is using different term than the other for saying weight, and maybe they even use different units of measurements. This is talking about kilograms, that's talking about pounds, right? All these things. It's very difficult for you to figure out what the meaning of that content is and how the two relate to each other, right? One product to the other product. So for that, that's the motivation for all these big search engine companies to get involved in this, right? To be able to understand the web. The other way to explain it, probably many of you are familiar with sitemaps, right? So with sitemaps, you describe what the structure of your website is, right? So you facilitate a search engine understanding your website by providing a description. You provide a document and you say, these are the links on my website. Now with schema.org and using RDFA, which I'm going to talk about later, which is one of the formats for embedding RDF into a web page, right? So inside the HTML. You can help a search engine to understand what your web page is about, what your content is about, right? And then of course it's actually good for everyone, right? Because now the search engine can do a better job at showing your page to the right users, right? Which is what everyone wants in the end. Okay, technical details. If you go to this website, schema.org, you will see some specifications for certain types of objects, right? So these are the schemas, recipes, reviews. I would say the stuff that makes up the bulk of the web, unfortunately. Right, so the silly videos, the recipes, and so on. Okay, next slide. So much for schema.org. Oh, actually, yeah. So if you go there, you see something like this, which is the documentation of the schemas. It's also available in an OWL format, in a machine-readable format. But this is the HTML version. So as you would expect, right? This is a definition of a local business, which doesn't fit all the properties here. But it says that it inherited these properties from place, and these are the properties, and these are the expected value type, right? And this is some definition, right? So the OWL file that's underlying this would include exactly the same information, not in HTML, but not in a standard format. Okay, next slide. It's actually the same slide, but differently. So so once you go inside, you get such an OWL file, which looks like XML, because it is. It is also RDF because OWL layers on top of RDF. But there are tools to process this. So this is the definition of what a local business is, and it says that it has 2 superclasses, and it has some description and so on and so on. And the attributes will be defined also in this file further down. Okay, next. And you can, as I said, you can load it into some standard tool. In this case, it's the Protégé ontology editor, which you can freely download from Stanford. You can load the schema.org ontology, and you can again browse, edit it, and those kind of things. Visualize it if you like the kind of visual graphical representations. Okay, next. Okay, so switching gears a bit, I want to talk about some of the source of data. So where does this data live on the web? So next. Okay, so we talked a bit about this already. That currently most of the data that's on the web is available in one of two forms. Either in HTML, right? So you have some kind of website generated, this traditional, Linux, Apache, MySQL, PHP website, right? So you generate some kind of pages from some kind of a database, right? In that case, you don't, or rarely have access to the database, to the MySQL database. That is not exposed to the world. What is exposed is the HTML content, right? Which you can collect and you can scrape, right, to your room. Or the provider of that website may give you some APIs. Now, APIs are kind of the test trap, right, of the web. They limit you in what you can do, in the sense that an API is essentially just a view on the database, right? It allows you to look at certain things from the databases underlying the website, but it doesn't allow you, for example, to combine information in ways that the creator of that website doesn't want you to. So to give an example, maybe you have a photo sharing website and they have the user API where you can search for users, and they have the photo API where you can search for photos. But maybe you cannot search for the combination of the two. Maybe you want photos by a particular user, right? And that's not possible because they just don't give you an API call for that, right? So that's what I mean when I say that APIs are sort of a limited view of the database. They are limited very often on purpose, right? To give you certain kinds of access to the data, but to make sure that you don't get the entire data in the first place because you're limited by API calls and how many calls you can make. And also there are certain combinations that are not easily done, right? Certain joins on the data set that are not easily done. So, so the semantic web will try to provide some solutions to that, and I'm going to talk about that. Okay, so that's the situation as it is. Now, as I said, what you can do is APIs, not much you can do, right? If they want to rate limit you, they rate limit you. If you want to scrape web pages, there are certain tools and methods to do that, to do information extraction on web pages. And I'll have some pointers to some tools that you can find on the web. It is the gray zone, right? So it is the gray zone of the web, and it depends on terms of service of a particular website, right? How much information you're allowed to extract from someone else's content, in which ways you're allowed to do that, right? So you need to sort of rely on the legal framework to know to what extent you can do that. The semantic web is designed to give some solutions, right? So first of all, it already gives you some formats that we talked about, right? To share your data in a way that is more open, because you share the data itself. And also, I'll talk about Sparkle and triple stores a bit. It gives you some tools also to expose the database itself, to expose the data itself to the web. And provide direct query access, right, as opposed to just API access to the data. So there are different ways that people publish data on the web. We already talked about this idea of linked data quite a bit, right? So that is people putting up these RDF documents that link to other RDF documents, right? There are standards, and there are a few slides on that, on how to put data inside HTML pages, right? So microformats, RDFA, microdata, these sort of things. The third point is that there are semantic web standards for exposing RDF stores on the web, right? So this is the equivalent of exposing, for example, a MySQL database on the web and giving someone SQL access to your database, right? It is a very powerful language. It is in ways more powerful than SQL. for querying graphs over the web, right? So if someone gives you such a Sparkle endpoint, then they give you query access to their data. The fourth way that people publish data is still less popular. Maybe most popular at the time is through different formats for data feeds, right? So you all know RSS. RSS has different extensions for including data in feeds. This is used actually quite a bit in some of the business world, in the industry context, where people don't want to share data publicly. But for example, if company A buys some data from company B, they might provide you such a data feed, right? Using some secure access. And in that context, some of these formats are used for sharing data across companies, okay? Okay, next slide. Okay, so linked data, again, you know, I will probably just skip most of the text here. But the idea is that, you know, you use URIs to identify things, you create links between things, and you make sure that these URIs are dereferenceable, in the sense that if someone actually plugs it into a browser, they get to some piece of documentation or some piece of data that describes what that thing is about. Okay. So, you know, in this vision of the semantic web, you know, there will be a URI for me. In fact, there will be probably multiple URIs for me. You know, maybe one maintained by Facebook, one maintained by Google, one maintained by myself or my own website, right? And these would possibly all link to each other also and say that, you know, this profile is the same as that profile, is the same as that profile. Okay. So that's the idea with linked data. Next slide. Okay, so just a bit of the background of what are the advantages and disadvantages for this for publishers in general. One advantage that I would point out is that data can be published independently from the original source, right? So an example is DBpedia. How many of you have heard of DBpedia? We'll look at it later. Okay. Okay, not many of you. So DBpedia is the structured data extracted from Wikipedia. So in Wikipedia, you have a lot of information that's sort of semi-structured in this kind of information boxes or tables that appear in the text. And what this project tries to do is to extract that information and put it into one central knowledge base, let's say. Okay? Now, this project is actually going on independently of Wikipedia, or has gone on for a very long time independently of Wikipedia. But they can do that. They can publish the data and they can point back to Wikipedia and say, you know, this is the data that describes that same concept in Wikipedia. Now, of course, you know, to do this, to publish linked data, there's some configuration that you need to do. There's some standards you need to follow. From again, you know, from the search engine perspective, some of the problems with this approach is that things need to change on our side as well. Right? So if you want to crawl linked data, we have to actually invest some effort into doing that. In terms of tools for dealing with linked data, I didn't put in crawlers, but there are some crawlers to collect linked data. I put in, you know, triple stores, essentially RDF databases that you can use. I'll have some more later. Some front ends. So if you look at DBpedia, and maybe we can look at it together later, they generate the HTML website essentially from the data automatically through this POPI framework. There are also tools for mapping relational databases to let's say either RDF databases or providing a wrapper that makes it appear as if it was a triple store, as if it was a Sparkle endpoint. Right? And some of this technology is used to expose existing databases. Right? Validators to check. Then there are many link data browsers that sort of allow you to navigate through this graph, right? And that's it. Okay, next slide. Okay, we talking about this. This is a very common visualization of the linked data cloud, they call it, where each of these bubbles is one data set, and the links represents links between data sets. There's a community of people I mentioned at linkdata.org that also maintain sort of a list of the data sets and try to generate this visualization to show how the community is growing, right? How new data sets are constantly added. There's another archive called the Data Hub, which you also referenced, which is again an archive or collection of collections, right? It gives you pointers to different data sets that you might want to use in your projects. I would say that a lot of success is mentioned already in the government domain, but there's data on very different things, right? Geo, companies, persons, publications, books, music, different data sets. Okay, next. Okay, the other option for publishing data, which is now becoming popular, is to put it inside HTML. Right? So to take an HTML page and put the data inside in a way that is easy to get it out for a machine. Right? So not for human presentation, but hidden in the code, hidden in the HTML code, in a way that's easy for a machine to extract. Okay. The advantage, of course, here is that it's easier to keep things in sync, right? And this is more browser and search engine friendly because you can also access the data from the browser, right? So there are browser APIs for accessing the data. And for search engines, again, they just need to take some part of the HTML document and get the data out. Now there are tools for converting, say, extracting data from HTML. So this N823 framework is actually one that supports multiple formats. Because unfortunately, there's some competition of standards here. So you might have heard of microformats, RDFA, microdata, essentially being competing, not standard, not all of them are standard, but competing formats to do very much the same thing. Okay. RDFA is an editor, so it allows you to create such an RDFA document, an HTML document with some annotations, and it helps you also to link to DBpedia, for example, from your documents. And RDFA Distiller is a tool that is somehow created by Ivan Herman from W3C, but I'm not sure if it's an official W3C tool for again extracting data and inspecting such HTML files for what kind of data they might contain. Okay, next slide. Okay, so the example here I put here, which came up in the question, is Facebook's Open Graph protocol, right? So what Facebook says is, if you're a publisher, if you have a website on the web, and you want to help Facebook to understand that content, then you put in some annotations. You use RDFA, or at least some subset of RDFA to do that, and that's essentially this thing. So it says, you define a namespace, which you're later going to be referencing here, and you're saying that this is actually a movie, and this is the title of the movie, and this is the URL of the movie, so I'm going to kind of link to URL, and this is an image of the movie, right? That can be used to represent maybe the cover, right? Okay, and they define also some schemas, right, for you to use, right? So for a movie, they'll tell you that it's going to have a title, it's going to have a type, it's going to have a URL, it's going to have an image, and some other things. Okay. Next slide. Okay, so this is becoming popular. This slide is just some statistics on how this has grown on the web. If you're interested in the statistics, you can read these papers. What I wanted to point out is this Web Data Commons project, which might be another interesting data set. What it does is it takes the common crawl data. How many of you know about common crawl? So, okay, so common crawl is this initiative to create an open, publicly accessible web dump, right? HTML corpus, HTML collection, right? I think they have something like 5 billion web pages. The way it works is that they put this data on Amazon S3. So the data is free. Unfortunately, you have to pay for processing it, right? So if you want to work with this data in your project, one of the problems might be that that you have to pay for processing the data. But they have 5 billion web pages. Okay, that's not too bad. And this other project, which is called Web Data Commons, it takes these 5 billion pages and it tries to extract all the RDFA and microformats and microdata that they can find. And again, they, as far as I know, they put the data not only on Amazon S3, but you can also download it from their website. It is probably a huge download. I haven't checked the latest dump. I think it's from February or March 2012 that they did this extraction and this dump. So that's a dump of the web, and the Web Data Commons is a subset of the data. Okay. Next slide. I think I can skip this. This is the historical growth of some of these formats. Next slide. Next slide. Next slide. Excellent. Okay, so just a few words about this API access that I mentioned, or query access. Some of the servers out there expose query access using the Sparkle protocol. Sparkle is both a query language, think of something like SQL, but for graphs, and it's also a protocol in the sense that it defines how do you take a query, how do you send it over the web using HTTP, and what's the result format, right? So it defines the communication aspect as well. It is very flexible in the sense that if someone exposes a data set with such a query access, you can essentially formulate fairly complex queries and do fairly complex joins. There are some nice examples on the Wikipedia website on this, so maybe we can put it together later or just in small groups. And again, if you use a triple store to store your data, this actually comes for free, because these triple stores, actually all of them, have the possibility to start up a web server, right? To start up a server and then expose the data that they have as a Sparkle service. Okay, next slide. Okay, so we could have done that demo here, but let's do that another time. If you want to collect this data, I already mentioned the DOMs, right? So for linked data, there's the linkdata.org website, there's the data hub. You can also do your own crawling, but at this point, probably if it's not necessary, you can avoid to do that. Again, if you want to collect RDFA data, I would recommend you to take a look at this Web Data Commons dump. Again, you could do your own crawling, of course. In this case, this is just HTML crawling, and then as you crawl, you extract data. So that's what you would do here. For example, using this N823 library, which can take an HTML page and extract the data. And then Sparkle endpoints, again, some of them are listed. The problem here is finding them, so you have to go to one of these websites, the linkdata.org or the data hub, where they have a list of them, right? But it's, they are not linked together in the way that HTML pages or RDF data is linked together. So you'll have to know the address of the endpoint. And when you know the address of the endpoint, you can send a query to it and get back a response. Okay, next slide. Next one. I think we're coming to the end, maybe 2 more slides. So, okay, so just some of the tools that you may want to use once you have some data, right? So the schema matching problem is is something that is fairly hard to automate. It is, in the semantic web research community, there's quite a bit of research work on how to map schemas. So let's say if you have two data sets and they use slightly different terminology for the names of the classes and names of the attributes. Maybe they're not even completely overlapping, right? Some has more information than the other. Some has a larger set of attributes, some has a smaller set of attributes. How do you find the mapping between these data sets and their schemas, right? So there are some tools for that, but it's still, I would say, in practice, largely a manual process. The tools for finding matches between instances, let's say individual records in the databases, are more advanced in the sense that they are more automated, and I put two there. One is called Silk, the other one is called Lines. So what they do is that, once the data sets use the same schema, they will try to find matching instances, right? So if there's a Peter Mika in this data set and there's a set of attributes, and there's a Peter Mika in this data set and there's a set of attributes, we understand how the attributes correspond to each other. Then these tools try to find out if they are the same or not, right? So they try to do some kind of similarity computation of these attributes in different ways, okay? And then there's also a tool for cleaning up data sets from Google Refine, that is fairly commonly used and popular. So you might want to play with that as well. Okay, next slide. And that's it. So I'm sure there's a zillion things that we did not talk about. I'm sure you will ask for ideas for hacks. Maybe you won't, but if you need ideas for hacks, then you can look at some of the previous competitions that people have organized and what other people have produced. There's something called the Semantic Web Challenge, challenge.semanticweb.org, which has been running for, 6 or 7 years maybe. And it's organized every year at the International Semantic Web Conference, and it's very much a competition. Not a hackathon like this, so it's not people sitting in the room together for 24 hours, but programming over a longer period of time and submitting some project. But you can get some ideas of what people do, what tools are they using, and what data are they using. There has been also at least one edition of what they call the linked data atom, which I'm not sure is even a word in any language, but it's a hackathon with linked data, and again it was organized last time, I think, around the Semantic Web Conference in 2011. There's a very good book. You will not have time to read a book in 24 hours, but this one is fairly efficient in the sense that if you're a Python programmer, this book will get you started in half an hour, I would say. If you're not a Python programmer, first learn Python, which will be half an hour, and then this book will be the other half an hour. Okay? It is very good. It's written by the guys from Freebase, who are now working for Google. It's a very good introductory programming book. We didn't talk about visualizations. There's this exhibit tool, which is again good if you just want to create some faceted browsing interface, or you want to do a map with data on it, these kind of things. There's an older talk from Dave Beckett on some of the open source tools that you can use. There's some tools produced by the Lot2 project. Again, you might want to check out. Okay. I think that's it. I think there's no next slide. Good.